All right, today I'm going to go over Chapter 2. Hopefully this will take around an hour because I've got something for you to do after that. So I'm on page 73 in the book. Some of this stuff we've already had. It's working with functions, data types, and operators. Most of this chapter concentrates on what are called named functions, which are the easier ones to deal with. They do explain to you what an anonymous function is. An anonymous function is one that doesn't have a name. But we will look at that, but not in much depth or breadth of coverage. All right, we will later on in the book. So, notice we don't have very many objectives here. Use functions to organize JavaScript code, use expressions and operators, and identify the order of operator precedence. All right. As they mentioned here, like most programming languages, what JavaScript allows you to do is take operations and segregate them. All right, so far we've been using integration. In other words, we've been putting pretty much most of the time putting everything in a main. That's not typically how it goes. Because if you've got 15 things that you want to do in a program and you put them all in main and now something breaks, if the program is really huge, you're going to have to dig all over the place for it. But if you've got 15 different operations that you want to do, and you break it up into 15 different functions, and now something goes wrong, ideally at least, you'll be able to jump right to where you want to go to fix it. All right? So the author says here in this chapter, you'll learn about also JavaScript data types and operations that can be performed on each data type. Now, JavaScript is a little different in that it looks at, for example, all numbers, regardless of what they are, all right, regardless of what they are of type number. But that almost sounds weird because they have both a parse int and they have a parse float. So even though they're all number, you can treat different variables as though they'll only hold whole numbers or as though they'll hold a number with a decimal place, and we'll get into that. So we talked back in Chapter 1, and you saw them in the examples that we went over with that payroll program. We talked about functions. All right, so a named function is a function, there's a surprise, that has a name. Where an anonymous function does not have a name. When you want to invoke a function, that's known as a function call. The reason I'm bringing that up, that's on your test. All right. It says generally you use a named function when you want to be able to reuse function statements. That's kind of important. Typically the reason that you write functions is you want to be able to reuse them. If you want to be able to reuse the function must have a name. So it must be a named function. If it's a one-time shot, if you only want to do something once, then you can have an anonymous function that is not named. What's the difference? Again, notice with a named function, it has a name. And with an anonymous function, it doesn't have a name. That is the main difference between the two. All right? There's a little bit more to it than that, but we'll talk about that stuff as we go on. Now, if I have this should make sense to you, what's up on the screen here in blue. This is a function invocation. I am calling a function. The name of the function I'm calling is calculate square root. What I am passing to the function is called number. This is referred to as an argument or a parameter, depending on the book that you read. All right? So I am calling this function and I am passing in that parameter. Not only that, we've talked about this before, this is referred to as an actual parameter because somewhere I will have had to have created a variable called number. Possible to pass in no parameters to a function, or like this one, pass in multiple parameters to a function. When you write a function, okay, when you write a function like this, they call these function braces. I just call them curly braces or braces. But the point is, this is the way that a function is set up. You need the keyword function. If it's a named function, then the name of the function. If it's an anonymous function, there'll be no name there. then you always need a set of parentheses, even if nothing is passed in. In that set of parentheses are any parameters that the function needs, and then all the stuff you do is between curly braces. Hopefully that makes sense. Again, we've looked at that in several chapters, so I don't think there really is probably a whole heck of a lot that's new as far as that goes. Now in this chapter, again, you're going to continue on doing the chapter exercises, and as they show on the bottom of page 76, you're working with this thing called fan trick photography. And this is the one that you're going to be working with. And you'll notice if you look in here, you'll be able to enter in the number of photographers that you have. Okay, at $100 an hour, of course, the more photographers you add, the more expensive that'll be. The number of hours to photograph, you can put that in there too. And what that'll do is based on these values here, and based on whether or not you want a memory book and reproduction rights, it'll figure all this stuff out, and then it'll give you, I guess there's also a travel thing here, but it'll also end up giving you a bill, for lack of better words. All right, so that's what you're going to do in here. So that's the completed form. All right, so this is the stuff as shown here on page 77. So what do we have? 100 times 2, which is 200. All right, the number of hours, which is 4. I'm not sure what that is. All right, but we've got 200, and here we've got 250. All right, so that's 450 right there. And then we've got the number of miles that you have to travel, which is 25. So we can figure that out by adding all that stuff. You can figure out exactly what the number of hours equals. I don't remember if they told you that on the previous page or not. All right, but the point is, what you end up doing in here is you end up adding all the stuff that's in here to give them a bill. So I'm not going to run through any of that because that's what you're going to be doing starting on the bottom of page 77, going on to 78, and in many other pages throughout the chapter. All right. So again, depending on the book you read, what you pass into a function is known as an argument or a parameter. Some books say that when you call it, that those are arguments, and when you use it in a function name, those are parameters. Some books say the opposite. It's not that important a thing. But an argument or a parameter is information the function needs in order to be able to do its job. All right? And if you say, well, that makes sense, that's all you really need to know. All right? Now, here's an example of another function. It's called calculate sum. And you'll notice that you're passing in 3 numbers, 3 values that'll be numbers. You're adding those 3 numbers together and you're putting them into a local variable called sum. And then you're using the document.getElementById to basically update somewhere on the screen where that exists. All right, so ideally what you're going to see when we keep going through this is how this stuff all ends up working together. All right, and what they get to in here, but not in a lot of depth and breadth of coverage, starting on page 80, is how events work. Again, remember, JavaScript, like most programming languages, is referred to as an event-driven language. It is sitting there waiting for you to do something. When you do something, if you have added code to that something, it'll react to it. And it'll react to it by doing whatever you put into that code. And that's what they're saying here. So in this example, you've got a submit button. When you click it, it's going to bring up an alert that says, thanks for your order. We appreciate your business. Now, this is the worst way you can write things. This is like writing a span statement that we did with CSS, because you are totally mixing your JavaScript right inside of your HTML. As we talked about last week, that's obtrusive JavaScript. That's the worst way you can do it. A better way you can do it, but still not great, is kind of like when we use the style tags for our CSS. This says, okay, I've got a button. When you click the button, call that routine. But we don't put the code for that routine right inside of our HTML. We do have the call to JavaScript right in our HTML, but the code itself is not there. That code instead would be inside of script tags in a JavaScript function. All right. So it's getting better, but that's still not a great way to do it. And the author mentions in here on page 81 a bunch of other things that you can do. Notice document.getElementById, submit on click. Again, in other words, what this is saying is, okay, find the button that's got an ID of submit button. When you click that button, call show message. Does that make sense? All right. This is doing an association. This is not physically calling show message. And the reason I know this is not physically calling it, notice that show message right here doesn't have parens after it. It's doing an association. It's letting the system know, hey, when the button is clicked, call that function. And if this doesn't make sense to you, you're going to have to read the book. All right. Now, they talk about how you can use add event listener, etc. And as it says right there, this option does enable you to separate HTML and JavaScript code, but it's a little poor in what you're able to do right here. We're going to get to the right way of doing it in just a minute. All right. But when you do something like this, and you can kind of tell, this is kind of sounds like a dumb thing to say after it, but notice that you're calling add event listener. So what does that do? It adds an event listener. It makes that association with JavaScript. You are letting the system know what you're planning on doing when some kind of an action takes place. Now, if you're using older versions of IE, you don't do it exactly the same way. If you remember, one of the things that we talked about when we talked about a little bit about Bootstrap 4 was we mentioned they're not going to support IE8 and they're not going to support IE9 anymore. They're not going to support anything that's before IE9 or before. One of the reasons for doing that is when you support all those older browsers, especially with IE, you've got to come up with all these hacks that people have put in because Microsoft at first refused to do things the way everybody else was doing them. All right? Now they're pretty much playing nice, for lack of better words. All right. On the bottom of the page, this might not look like it's important, but I want you to understand it. Please make this change in your book. To my knowledge, that's a mistake. This is the bottom of page 82. It says document.add-event-listener. I believe that's a mistake, and you need to put the word window right there instead of the word document. I think that's one of the things that you're supposed to do in the assignment that's throughout the chapter. I believe that's a mistake. I've got it annotated in here. Mistake, it should be window. All right. But again, you're going to walk through these steps, and the next thing they have you do, this is going to be the first time probably for most of you, is they're going to have you go in and look at the browser console. In other words, they're going to have you look at how to debug a program. Well, in Chapter 3, we're going to go through arrays, okay? But then after we go through arrays and a few other things, in Chapter 4, the entire chapter will be on debugging. So if you want to start to learn how to debug, the exercise that's on pages 83 and 84 and 85 and 86 will get you started. They won't make you an expert. Bless you. I don't know if anyone is actually an expert on debugging. Many people know exactly where to look for something when there's an error. All right? But it's very much a learned type of thing. Okay, most people can't just look at code, I know right where it is. Some can. The more practice you have, it's kind of like being an auto mechanic. Somebody comes in, and if they may have described the way their car sounds, but if they actually bring it in and the mechanic hears it, then he or she can typically say, I know what that is. All right? You've got a belt loose, or whatever it happens to be. When we turn up to page 86, JavaScript functions can have return statements. by default, a return statement returns a single value. That's not exactly true, but we'll have to wait till the next chapter to talk about why that's not exactly true. If you don't want to return anything, you don't have a return statement. You just leave it off. You can put return semicolon, but no one does it. So this would return a result. So probably you would have something like this. You would say, for example, result equals average numbers. I put this all in one line, but you can see I'm running out of room. So I put in there maybe, I don't know, 56, 23, and 67. All right? So result equals that. So what would it do? It would add these three numbers. So it would add 56, 23, and 67. If I did it right, it's 146. Then it would take that and divide it by 3. All right, 146 divided by 3 is about 49, approximately. So it's going to grab that 49 that it's going to figure out right here, and it's going to return that, and it's going to shove it into result. Does that make sense? That's exactly what's going on here. I mean, it's no more complex than that. But you have to understand that if you want to write yourself a function, and again, why do we do this? Well, what if I'm writing a calculator? Okay, and I want to give the user the opportunity to add two numbers, subtract one from another, multiply two numbers, divide one by another, or do a modulo. The good way to do that is to have a different function for each one of those things and set the result to the result of that function. All right, and that's the kind of thing that they're talking about here on page 86. So again, you'll run through this. Now, they go through a couple things in here, and this is a very important point. This is on page 87 in the book. Remember how I told you, and we've been doing this all along, that you put the word var before you declare a variable? Okay? If you are working in a function, so if you're in a function and you declare a variable in a function, and you don't use the word var, the variable is automatically global. You understand what I'm saying? It means that when you use var in a function, that means that variable can only be used within that function. But if you leave the word var off, it can be used anywhere. That's considered piss poor programming practice. You shouldn't do that. You should always put var, even if it's defined outside of any routine. It's just considered good programming practice. All right? But one thing about this, and it's not right here, but when a global variable is one that's declared outside of a function, so it's available everywhere. A local variable is declared inside of a function, so by default, it's only available to the function where it's been defined. All right. Now, on the bottom of page 88, and the author does not do a good job of explaining this, but what if I have this? What if I have var a equals 27, all right? And then I've got some more code down here, and now I call a function. I say result equals add 2, and let's just say I'm going to pass in here B and C. So B and C are defined in here someplace. So now I've got in here function result, B, C, and I don't care what's going on in here. I've got some code in here, but in here I put in var a equals 71. So notice I've got an a defined outside of the function and an a defined inside of the function. If I'm inside of this function here, that's the a that I use. If I'm outside of the function, that's the a that I use. This a right here, it's what's known as this a shadows that a. So you can't technically use the one that's defined outside. And if you say, wouldn't it just be easier not to call two? Yes. Don't call them both A. It's not a problem then, but just so you know. All right? And they start to explain that on the bottom of page 88, and it goes on to the top of page 89. I just wanted to get you familiar with the concept. All right? Now, starting on the bottom of page 89, they have you add global variables. All right, it goes on to page 90. I'm not going to go through that because we've already looked at global variables. that are defined outside of any kind of function. All right. There's a chart on the middle of page 90 where the author defines some built-in Java functions. To be honest with you, the ones that we're going to hit on almost exclusively in here will be maybe a little bit on eval, but will be is NaN, which we've already talked about, is not a number, parse float, and parse int. The other ones, it's not that they're not important, but they're not ones that we're going to talk about as much. All right. All right, so you work with these functions. Functions do what? They work with data. Data is what? Data has types. These are the 5 types of data that you have available to you in JavaScript. Any kind of number, Boolean, which is true, false, any kind of string, which is in either single quotes or double quotes, undefined, which means that you've defined a variable, but you've declared a variable, but you haven't given it any kind of number. And null, which takes any kind of value the variable has away. All right? So if we look on page, this is one of the better programs in the book. And it's really short. It's not even a complete program. But if you look on page 92, because this explains to you how all these numbers are used. So notice you come in here and you say var state tax. Everybody see that in blue? Then you write it out. So you've declared the variable, but you haven't given it a value. So what's its value? Undefined. So an undefined variable is one that's been declared, but not yet initialized. All right? Then you give it a value, and you print it out again. So what does it have? The value 40, because that's the value you gave it. Then you set it equal to null, and you write it again, and now its value is null. Null means unknown. All right? So again, all of you in here, unless you've taken another class here previously other than Colin, you don't have a GPA yet. Your GPA is null. It is unknown. All right? Now they talk about some different kinds of variables here, starting on page 93, but the real big thing is here. JavaScript is what's called a loosely typed programming language. The author says duck typed. I've never heard of that before this book. But a programming language that's like that, all right, that's loosely typed is one that has not been defined. I thought you weren't coming till 9. I thought you weren't coming till 9.
8:30.
Oh, okay. All right. Well, I'll tell you what, if he doesn't mind sitting and listening to about a half an hour lecture, then I got a thing planned for everybody. No? You can come right over here if you want. That's fine. Thank you. So JavaScript is what's known as a loosely typed programming language. What that means is you don't declare a type. Next semester we'll be going through C#. And if I want to create a variable called age, and I want it to be a whole number, I have to say like int age equal 21, meaning that it's a whole number and its value is 21. In JavaScript, I can say var age equal 21, but since it's loosely typed, later on in my program, I can turn around and say age equal hello, and it'll work. And then later I can say hello or age equal false, so I can keep changing the type of variable or the type of value that it holds, because it's a loosely typed programming language. So programming languages are all either strongly typed, with like C# or loosely typed like JavaScript. Other than JavaScript and PHP, most programming languages that you use are strongly typed. All right. Now, because of the fact that JavaScript is loosely typed, that's one of the reasons it actually reacts slower than a lot of other programming languages do. Because the system has always got to go and do reconciliation. You know, when you talk about reconciling your checkbook at the end of the month, all right? My brother called me, or actually I called him this weekend. It was his birthday. And we were talking about my mother, and he said how he's been reconciling her checkbook because it's never correct, all right? But when you talk about JavaScript, if I say var age equal 21, the system knows it's a number. Then if later on in my program I say age equal false, I don't know why I do that, but I can. Now the system has got to say, oh, it's not a number anymore. Now it's a Boolean. And if later on I say H equal hello world, now it's not a number, it's not a Boolean, now it's a string. So it's the way that JavaScript works, being loosely typed like that, it is going to actually execute slower than strongly typed languages, because it figures out the value in the data type of the variable at what's called runtime, so while the program is running. When you've got a strongly typed variable, it figures out the type of the variable at compile time, and then it can't change. So those programs will execute faster in those kind of languages. All right, so hopefully you all know this, but an integer is a whole number. An integer or an int is a number that can't have a decimal place. On the other hand, a floating point is a number that can have a decimal place. All right? That is basically the difference between the two types. So again, you run through there, and on pages 94, 95, and 96, you go through some more examples in this photography thing that you're working on. All right, so you'll have a chance to go in and work with a bunch of the numeric types of variables. Then on 97, you start talking about Boolean. Boolean can only have two types of values. So if you declare a Boolean variable true or false, that's it. Some programming languages allow Booleans to be set to null. Technically in JavaScript, if it's a Boolean, it can only hold true or false. All right? So, something like, a lot of times with a Boolean variable, you'll start it with the word is. You don't have to, but a lot of times people do that. Is married. True or false. There is no gray area. All right? Is pregnant. Are you pregnant? Well, maybe, kind of, sort. No, you are or you're not. All right? That's the, with computers, there's no gray area like that. So again, you start working with Boolean variables on pages 98 and 99. This is all through that trick photography thing that's in the chapter. All right? Then we jump into strings. We've already done work with strings, so you've already looked at these. Strings, remember, have to be within double quotes or within single quotes. You already know that. All right? And there really is no difference between doing it within double quotes or single quotes. Remember, when you want to glue stuff together, you use the plus sign. Another way you can do it is like this. All right, so this line right here, this line where it says destination plus equal, is the same thing as saying destination equals destination plus is in Hawaii. Get it? Does that make sense? Not only is there a plus equals like this, there is a plus equals, there is a minus equals, there is a times equals, a divide equals, and a modulo equals. They're all shortcut operators. All right, do you have to use them? They will actually, this right here will execute faster than this. It'll break down to its machine language equivalent faster. All right, plus it's less typing, which is why most people do it. All right, turning up and looking on page 101. Andrew, I think you were the one who asked this a while back. What does that \n stand for? And I said it was a new line, which is a combination of a carriage return and line feed. There are different escape sequences as shown in the table on the top of page 102. The ones that you're going to use 99% of the time are going to be these two. To add a tab or to add a blank line or go to the next line. I don't mean you'd never use any of the other ones. I've used this one before. I don't know if I've ever even really used many of the other ones. This is kind of an important one too, because you could, if you want to put down a Unicode character, you can use these. All right, but I'd say 99.9% of the time it's going to be those two. \T for a tab, \N for a new line. Those are the ones, at least for now, that you should worry about. All right. Bottom of page 103, they talk about using operators to build expressions. We've started talking about this in the previous chapter. On page 104, there are your arithmetic operators. Okay? Now, I'm going to put something on the board. You may remember it, you may not, you may care, you may not. All right? But I want to talk a little bit about this increment and decrement thing that's here. So I come up here and I say var A equals 7. All right? Then I've got var B, and I'm not going to give B a value. But later on in the program, I say B equals A plus plus. I want you to understand what happens when I do this. All right? This is called the pre-increment operator. What it does is it takes BA and it assigns it to B. So right now, B is 7 and A is 7. Does that make sense? Then it adds 1 to A. So that becomes 8. See that? So when I get done and I use, and boy, that was nice. It's not the pre, it's the post. If I put the plus plus afterwards, I do the assign, and then I add 1 to it. On the other hand, if I had said B equals plus plus A, that is the pre-increment. That will add 1, so this is 8, then it'll assign that to B. See the difference? That's 7, that's 8. Here, they're both going to be 8. And if you say, that's really confusing, especially when you're first starting to program, then don't use it. Or break it up into 2 lines. It's going to run a little slower, but then do it that way. Most of the time when you use the plus plus, you're going to use it inside of a loop that we'll talk about in the next chapter. All right? But there's a pre-increment and a post-increment. You can only do that to add 1 to a variable. That's it. Okay? Not only is there a pre-increment and a post-increment, there's a pre-decrement and a post-decrement to subtract 1 from something. All right? And we'll look at those in more detail later on. I already mentioned these to you, the plus equal, minus equal, etc. All right? How about these? This one looks really weird. 3 equals. And again, I'm going to just throw a little code up here on the board, and you have to tell me if it doesn't make sense. If I say var A equals 0, var B equals double quote 0 double quote. This is the number 0. This is the string with a 0 in it. Technically, they're not the same thing. All right, you may or may not agree with that, but technically they're not the same thing. But if I do this, if I say if A equal B, it comes back as true. The system thinks, yeah, they are the same thing. What you're going to see in just a couple minutes, and I don't know who the hell came up with this naming convention, but JavaScript has what are known as Truthy values and Falsey values. And this are both Falsey values. That's why when you say if A equal B, that'll come up as true. All right. If you want it not only to check to see if the value is the same, but the type is the same, you use 3 equal signs. All right. This is called equality. This is called equality and identity. All right. Here, that'll be true. Here, that'll be false. And it's something that, especially as we go on, and we'll go on later in here, and we talk about validating forms and stuff using JavaScript, using that triple equal sign will become really important. There are other things that are in here. Oh, I guess I skipped past that. We're going to be going through logical operators, and 2 ampersands, or 2 pipe signs, not an exclamation point. All right? So we're going to be talking about all of those as we go on. And virtually every programming language has all those. There's some special operators that are shown on page 105. We're not going to talk about those right now. All right? So The arithmetic operators, you turn up to page 106. This shouldn't be a real big surprise to you here. Addition, subtraction, multiplication, division, all right, and modulo. Okay, and there's code examples on the bottom of page 106 going on to page 107. The one that, again, is different to most people is the modulus, which is the remainder operator. Anybody want to guess? When would you use modulus? There's two basic times. When do you need to break something up into, kind of components or whatever? I'll give you a hint. One of them is time. Hours, minutes, and seconds. Can you think of another one? How about currency? Dollars and cents. All right? So when you write programs where, let's say I was given a number of seconds, and it was 3,147,687,123. And I wanted to figure out the number of years, the number of months, the number of days, etc. I could do all that stuff. And I would probably end up using, the modulus operator to do that. Or if somebody said, I'm going to give you 70,312 cents, and you tell me how many dollars that is. All right, you're going to use modulus for that as well. On page 109, but we've already talked about it, they show you on page 109, as soon as I can get there, the plus plus and the minus minus. All right. Am I wrong in assuming that you all know that if I say this, var salary equals 10,000, all right? That says your salary is 10,000, right? If I do this, technically you're working for free and you're paying me 10,000, correct? You may or may not know that when I say this, it's totally legit to do that and put a plus sign before it. You never see it because it's assumed that if you don't put a minus sign there, it's positive, but you can put that in there if you want to. All right? If you need more on the example that I gave you, they call it prefix and postfix. I called it pre-decrement or post-decrement, pre-increment or post-increment. All right, but it all works the same way. And it'll only be used to add or subtract 1. Turning up all the way to page 112. On page 112, they talk about assignment operators and the compound assignment operators. We just looked at these. All right. So I'm going to assume, looking at that chart that's on page 112 in the book, that if you were given a problem like that, that you'd be able to figure out how it's used, what it's doing, etc. Does that make sense to everyone? And there are examples that are in the book as well. All right, they give you a program example here that runs through all that. All right. Then jumping up to 115, 116, 117, and the top of 118, more examples with this trick photography thing that you're working on in here. Okay? On 118, on the bottom of the page, they give you the comparison operators. I've already mentioned equals, the equals versus the triple equals. Notice the not equals versus the not double equal right there. All right, greater than, less than, greater than or equal to, less than or equal to. The key one is the double equals as opposed to a single equals. And I will tell you that most good JavaScript programmers very rarely, if ever, use the double equals. They just use the triple equals all the time, which again is equality and identity. All right, to make sure it's of the same data type. Now, JavaScript is another one of those programming languages that also provides what's called a conditional operator. So I'm going to put some code on the board here. I'll write it down here. So if I come down here and I say var a equals 21, var B equals 17. And then I'm going to say var max. All right, I'm not going to give it a value. But let me just come up here then and say, if A is greater than or equal to B, max equal A, else max equal B. Does that make sense to everyone? All right. Well, what you may or may not know are a couple things. First of all, if there's only one line after an if or after an else, you don't even need the curly braces. So that'll work just fine. That's considered, again, poor programming practice, but sometimes people do it. Now, what you may or may not know is I can also do this. Max equal A greater than or equal to B, question mark A, colon, B. So this one line right here does exactly what this is doing right here. This is saying check and see if A is greater than or equal to B. If it's true, you do what comes after the question mark. So you take A and you assign it to max. If it's false, you do what comes after the colon. So you take what's in B and you assign it to max. Does that make sense? All right, I'll leave that one up there for a couple minutes. But it's called the ternary operator. Some books call it the question mark colon operator. So it goes by different names. All right, and they give you a code example of it on the top of page 120. But again, it's very similar to what I just showed you. Then on 120, 121, 122, going on to 123, all right, they have you work some more with this trick photography thing that we're working with, all right? Now, please look on the bottom of page 122. Notice these values that are right here, double quote, negative 0, positive 0, NaN, those four, plus these two, null and undefined, those are what are known as those Falsey values. All right, so anything you do with those is going to come back as false. Okay, anything not those are truthy values. You're going to have to read that for probably having it make any sense to you. Bless you. The logical operators, again, are the and the or. I'm going to put an example up here again. I think it's important enough to do this, to just take a minute to look at this. So if I come up here and I say var A equals 27, var B equals 31. And then I say if A is greater than 10 and B is less than 50, all right? What I want you to understand is when you use and like that, both of these have to be true. So you tell me, is A greater than 10? Yes, it is, right? Is B less than 50? Yes, it is. So whatever comes in here, I will do it. Does that make sense? All right. Let's say that we did this. Let's assume that we said if A is greater than 30. All right. Would you agree now the first part's not true? 27 is not greater than 30. So if you have this, if you have an and condition where you're testing two things, if the first one is false, you don't even test the second one because there's no reason to do so. All right. So let's put it back to 10 again, and let's change this from and to or, which is the pipe sign. Now this is true, correct? It's greater than 10. Since that's true with an or, if either one is true, the whole thing's true. So if that's true, you never check that one because there's no sense in doing it. It's just redundant. All right. That's built into most programming languages, that if it's an and condition and the first part is false, you don't check the second part. If it's an or condition and the first part is true, you don't check the second part. All right. There's also not, which is the exclamation point. We've looked at that. If you remember, if not is not a number, etc., that kind of thing. So we've looked at that before. So those are your three operators, and they're shown in the book on the top of page 124, and in the chart right here. All right. Now, nothing at all wrong with what the author did there. Okay, they put them in alphabetic order. No, they didn't. A, O, and N. But what I want you to understand, I don't care if it's on a test or not, but you can write very complex expressions with a lot of this stuff. And what I want you to get out of this is if I write a very complex expression that has nots in there, and it has ands in there, and it has ors in there, you do the nots first, then the ands, then the ors, because you're going from the most restrictive to the least restrictive. All right? And if I have a bunch of these in there, I'm going to do all these, then these, then these. If I want to change that order, I use parentheses. All right, we already talked about circumventing the order using parentheses before. All right, on page 125, on the bottom of the page, they've got some special operators there that you can see, and it goes up to the top of page 26. The only one that we care about right now is this question mark colon. We'll look at a bunch more of them as we go on in the semester. And again, there's a few more that are shown on the top there of page 126. JavaScript has a special type of operator that's called the type of operator that shows you the type of data you're using. Notice what it comes back with. If you're working with a number, it comes back as number. If you're working with a string, it comes back as a string. If you're working with a Boolean, it comes back as a Boolean, etc. All right. Again, the ones we care about right now more than anything else are number, string, Boolean, and undefined. All right. So on the bottom of page 127 and going on to page 128, they talk about what's called operator precedence. So if you've got really complex expressions with all of this stuff in there, all the stuff that's on the bottom of page 127 and it goes on to page 128, there is an order of precedence. Okay? And when you think of an order of precedence, it's kind of like a hierarchy chart. Okay? So there are certain decisions here that I can make for this program. But there are certain other decisions, for example, if they involve spending money that's not my own money, I've got to go to Mr. Corrigan. Does that make sense? Okay, because that's the way that the hierarchy works here. And if we get to a certain point, he can okay expenditures that are not maybe that big, but let's say it was $10,000. He doesn't have the authority to do that. So it's got to go up the chain to Mr. Pohl, who's the vice president of the institution. All right, and then he can sign off on it or not. When it gets to a certain point, it's over his pay grade, and it goes to Mr. Schoen, who's the president of the college. All right, the same kind of thing works here, where if you've got an expression with a bunch of stuff, you do it in a certain order. And if you want to be able to circumvent or change that order, you use parentheses. All right? And that was quick, but that was the chapter. So what we're going to do is let's take a break, all right? And let's come back at 10 after, and we're going to do 3 things when we come back. First thing we're going to do, as we did in the last chapter, is we're going to go over that quiz that's at the end of the chapter. All right, it's first thing. Second thing, I already have your test review done. I just have to mail it to you. So I'll email that to you during the break. We'll spend about 10 minutes going over that. Then I'm going to ask you to try to do an exercise. And I'm breaking you up into groups of 3. I didn't know where you'd sit, so I'm put you in the group over here. You 3, I did it all based on where you're sitting. You 3 will work together. All right, Ryan, you 3 will work together, and then Eli, you'll come over here and work with them. And I'm going to give you a problem, and I'm going to ask you to work on it and give me 3 solutions for it. I'm going to give you about an hour and a half to do that, and then I'm going to show you the way that I did it. You're not going to be graded on this. You're not going to have to hand it in. All right, so for that reason, what I'm going to ask is it's not that different from what we did in the payroll examples. I'm going to ask that you not use those. You're just talking amongst yourselves and see if you can solve the problem without having to use the internet and without having to use notes or even your book. If you have to use your book, that's not a bad thing. But I don't really want you to use the internet or your notes, because if you use your notes, you've already got that information. I want to see what you can do on your own. You're not turning it in. I don't care if you have one person who does it and they're kind of the recorder for everybody, then they email it to the other two, or if you each do your own, that's totally up to you. All right, so let's take a break. When we come back from the break, we'll do the test review and the quiz at the end of the chapter, and then I'll pass this thing out to you after that. All right, so let's come back, please, in 10 minutes.